morning. So this will be my first time doing a silent session. So hopefully it goes well for all of us, and hopefully the translation works out well. So I'm Chad Lingmann. I'm the AWS Game Tech Leader. I have a great privilege of working with our technical field teams, solutions architects, technical account managers, professional services, and support of games customers worldwide. And it's my pleasure to speak with you today about the global growth strategies for games with AWS. So here's what we'll cover today. We have Amazon GameLift servers. We'll go into a little bit more depth than we did in the keynote. So a lot of these topics will be a little bit more depth than we did in the keynote today. Game backends and infrastructure on AWS, and game analytics on AWS, and then we'll talk about some key takeaways. So Amazon GameLift Servers is a purpose-built AWS service that allows a studio to deploy and operate cloud game servers for multiplayer games globally. Now, as player geography changes, GameLift servers can scale the game servers automatically based on player demand and your desired configuration. You can even deploy a single GameLift fleet across regions, local zones, and that allows you to have latency-based matchmaking. The service itself is highly available and flexible. You don't have to use all the features of GameLift. For example, if you want to use your own matchmaking and GameLift for game servers, you can. GameLift Servers has global coverage in 23 regions or local zones across 5 continents. It's fully supported in all the regions of the world where players play games today. And GameLift Anywhere even allows running game server fleets outside of the managed AWS infrastructure. So this can extend your game server placement for lower latency when needed. Or it can be leveraged for local testing of game builds to accelerate your development. And even containers are now available for use in GameLift. So you can now easily run containerized game servers for easy deployment and portability. Now, if you're interested in learning how to run containers on GameLift servers, you can find more information here on how you can speed up your onboarding process. So there's this QR code here you can take a look at. We have something called the GameLift Container Starter Kit, and this is a blog post that describes how to use it. So the Container Starter Kit helps a game developer get started with multiplayer game server hosting on containers in less than an hour without installing any additional tools or SDKs. So if we take a look, we'll start probably here in the black numbers. So we'll start with number 1 there. Game developer uploads a game server build with the Container Starter Kit wrapper to Amazon S3. Then the game developer triggers a new build on AWS Code Build. Number 3 there, Code Build builds the Amazon GameLift SDK wrapper and builds the game server container image, and then uploads the image to Amazon ECR. So Code Build then updates the Amazon GameLift container group definition and deploys a new version to your GameLift fleet. And then Amazon GameLift downloads the image from Amazon ECR and updates the fleet with the new game server version. So now if we take a look at the blue area here, the GameLift client will request a game session, and in the selected AWS region from the Amazon API Gateway, HTTP API. AWS Lambda function then searches for an existing game session with the Amazon GameLift API, or it creates a new one if needed. And it then creates the player session, and it sends the information back to the client. So in this scenario, an Unreal game client then connects directly with IP import to join the game. So GameLift allows you to easily deploy your game builds into your local region and also into global regions where you'd like to expand your game into. This gives you an idea of what that might look like. So placing the game servers closer to where your players are at is drastically simplified when you're using GameLift in any of the 32 different locations today. The GameLift servers team also plans to expand this number to 55 locations by the end of 2025. So Amazon GameLift Servers provides multiple options for hosting your game servers. First, we have the classic approach, which is using those game servers where you pack your maximum amount of game sessions per server. And that setup is simple and great for game migrations. And then the second was the support for containers, which we just talked a little about, the container starter kit. Uploading your game server build as a container is fast, and each game server is actually still isolated. And you can also customize that with the Docker file. And then finally, we have the GameLift servers anywhere that I talked a little bit about already, which allows you to register your own compute and leveraging that different infrastructure hosting locations. So recently, we wanted to demonstrate GameLift servers matchmaking at scale. So you might think 100 million is arbitrary, but if you take a look at some of the unofficial tracking data, it indicates that the most popular games in the world today top out around 14 million concurrent users individually, or CCUs. And 100 million is also at least 2 times the estimated peak CCU traffic of all games on Steam concurrently, and more than 5 times the largest individual multiplayer game out there today. So we were actually able to successfully demonstrate GameLift scaling to 100 million CCUs, which you can read about in more detail in the blog linked in the QR code right here. So I encourage you to go out and take a look at that. So when the Respawn team was faced with the need to move from on-premise to the modern cloud game server infrastructure, they did utilize GameLift. I mentioned that earlier today, so we're going to talk a little more detail about that. With millions of players worldwide, Respawn needed more visibility. They needed more consistency and more flexibility in their infrastructure. And a core priority for Respawn was conducting integration and technical validation without disrupting the development team or the Apex players. Now, AWS was able to meet the need by working with one of our partners, CodeWizards Group, and leveraging the Amazon GameLift migration support program to deliver a thorough, phased, and low-risk migration plan, resulting in one of the largest ever AWS-led infrastructure transitions completed for a live service game. The first step was to build a player redirect layer that could reroute the players to Amazon GameLift servers without changing the game backend logic, which avoided risky code changes and unnecessary QA cycles. It was a system that automatically migrated the players to upgraded servers after their match ended, and it deployed updates without interrupting the gameplay at all. So the next part was a game server wrapper. It was also created, which allowed them to use the existing game server build without change and to add observability and logging into the existing build. So after evaluation and due diligence, Respawn moved forward with a phased, region-by-region traffic cutover to Amazon GameLift servers. Starting with the smallest geographies first, they moved them one by one, ensuring confidence along the way. Now, with the scale of GameLift servers and the solid technical preparation, Respawn successfully migrated millions of players over only 10 days. You can read a little bit more about it here from this blog post. So Respawn also reported publicly major technical wins. First, latency dropped an average of 30% globally. Packet loss also decreased by 5% globally, with certain areas improving up to 50%. These are real, observed metrics from Respawn's telemetry. During the migration process, the GameLift team also helped them improve their matchmaking logic. Respawn was also able to consolidate their infrastructure down from 15 different hardware variants to just 2 instance types. And the Respawn Twitter post and image shown here spoke directly to the impact. Post-migration matches experiencing rubber banding and hit registration issues decreased significantly. So when complete, Apex Legends didn't just migrate to GameLift servers. They actually saw meaningful improvements and had a seamless experience doing it. All right, let's talk for a moment about the Squid Game Unleashed. This is that multiplayer battle royale game for up to 32 players that uses Unity, and it's from Netflix Games. Its worldwide launch coincided with Season 2 release of the show. Netflix Games utilized GameLift servers and GameLift Anywhere to speed up the development and testing process, which allowed their engineers to focus on the game itself, helping them to build this multiplayer game out in less than 10 months. They maximize the usage of their servers by running multiple game servers instances on each host in their game server fleet, the GameLift fleet, and utilize Flex Match for making the matches. It was a #1 hit in the App Store in over 109 countries. So why did Netflix choose GameLift? Now, they knew it would be a challenge to wrangle their global player base and to get them to satisfying matches with other players, and they had real potential for hit, which would require massive deployment of game servers at scale. And to make matters even more fun, this was the studio's first truly multiplayer live services game. This meant they had no pre-built game tech to reuse. So they leaned on GameLift servers to provide a solid basis for their multiplayer architecture. Using GameLift fleets and Flex Match to deploy a fully managed global multiplayer architecture quickly allowed Netflix games to complete the build in that short 10-month window successfully. Pre-built scaling and matchmaking removed the need to engineer core multiplayer infrastructure, enabling an on-time worldwide launch. The need to place tens of thousands of players into fair, low-latency matches across multiple regions and continuously monitor live quality could have been an impossible task without GameLift integrated Flex Match. Using its custom telemetry and CloudWatch insights, the team built real-time dashboards and to tune the legacy buckets, optimize fleet placements, and rapidly troubleshoot, ensuring smooth gameplay and quick fixes for players. During the peak of development, the team generated 30-plus builds per day, and they had to update the server version safely, clean up old builds, and minimize infrastructure costs. With GameLift, they were able to set up version-centric deployment methods, using GameLift Anywhere, fleets, and CDK automation. This enabled hotfixes and server-only updates without downtime, and automated stale build cleanup and scaled resources efficiently. So here's an example of what the GameLift stack looks like for Netflix. They had one requirement, which was the ability to update and delete resources for a game version with no impact to other running versions. Now, although they primarily used Terraform for resource deployments, Terraform was not used for version GameLift resource deployment due to the challenges associated with the shared Terraform state across the full versions of the game. Ultimately, the customer chose to use AWS Cloud Development Toolkit to model GameLift components for each version deployment of the full game stack. This allowed for separate version testing with no impact to other running versions. And now Netflix wanted every member of the team to have the ability to make changes without writing CDK code. Things like fleet instance types, number of processes per fleet instance, and locations were all updatable via a config file. Since they knew they would likely need to make rapid changes to matchmaking rules, adjusting the player behavior, they built a special deploy process which pushed the matchmaking changes live with no interruption to player experience. And since I mentioned it, here's the Cloud Game Development Toolkit slide from the keynote again, so you can grab a link if you'd like to check it out. Now, I mentioned GameLift Flex Match. Let's expand a bit more on what that is. GameLift Flex Match is a fully managed matchmaking service that scales from a 2-player game to a 200-player battle royale. It can be used standalone with your own game server hosting solution or fully integrated into managed GameLift. Let's walk through the essential GameLift APIs for matchmaking and session management. Start Matchmaking is your entry point. You call this API when players want to join a match. It takes a matchmaking configuration ARN and player information, and then this kicks off the matchmaking process based on your Flex Match rules that you set up previously. Once Flex Match finds a suitable match, it can either use Start Game Session Placement to place the match in existing fleet, or use Create Game Session directly if you're managing your own hosting. Create Game Session initializes a new game session with specific configurations, like maximum player count and game process properties. And then finally, Create Player Session reserves a spot for each player in the game session, providing them with connection details to join the game. So think of this like a pipeline. So start matchmaking, to start game session placement or create game session, then to create player session. Each step moves the player closer to actually joining their match. Now, a few of the areas that we're investing in with GameLift. Iteration speed is one of those big ones. It has reduced dramatically with the use of containers and the ability to spin up a GameLift fleet in 10 minutes versus 45 minutes. In addition, the onboarding improvements with container starter kit and SDK wrappers, updates, we're improving tooling to give you more visibility into how your game is performing. GameLift will offer additional visibility into the player experiences, server performance, and cost breakdown. We now have UDP echo servers, for example, that allow you to ping your game servers and see what the performance and response time is for your players. What is their actual latency? And in the future, GameLift will help monitor and detect anomalies, and even suggest actions based on the data observed. Now let's talk a bit more about running games on AWS. So AWS is the first major cloud provider to launch our own general purpose processor, AWS Graviton, which delivers up to 40% better price performance when utilizing 60% less energy compared to x86-based instances. With Graviton 4, we expanded our performance gains from Graviton 3 even more. Graviton is designed with efficiency in mind, with each generation deploying improvements in the processor architecture. Graviton is architected based on real-world performance instead of traditional benchmarks. This translates to chips that deliver performance efficiency for customers' cloud workloads instead of chip features that are not applicable. Since day one, each Graviton vCPU is a physical core. This design choice translates to scaling consistently even under load. Graviton innovation and generations are moving quickly, including modern technologies. And for example, Graviton 3 was the first in the cloud to support DDR5 memory, which is more energy efficient than DDR4, and also allows for higher memory bandwidth to improve workload performance. Beyond the chip design, AWS is also innovating on the server. For example, Graviton 4 servers are configured for power savings when the two sockets are not in coherent mode. Another example on Graviton 3 is the servers are designed to fit 3 processors in the same server, which improves the processor density in a rack by 50% and enables optimal use of rack power, space, and materials. So AWS, many open source communities, and independent software vendors have optimized software solutions for ARM already. So many applications and workloads are already able to run on Graviton. For example, Unreal Engine can be natively compiled for AWS Graviton, enabling developers to run and deploy game servers, build pipelines, and studios on these cost-effective, high-performance instances. So with the performance efficiency enabled by Graviton, customers have great flexibility to right-size their compute clusters, while they still meet the same or better service level objectives for their workloads. Customers are able to reduce the fleet size, reduce the instance size, or even do both sometimes. By continuing or consuming fewer compute resources for the same business outcome, customers are operating their workloads more sustainably, both environmentally and economically. So in addition to EC2, Graviton is also supported by AWS managed services, including database, analytics, container, and serverless, and also our machine learning services, and you can see Amazon GameLift is there. These services make adopting Graviton as easy as switching the instance type. Most of these services offer Graviton by default today. Now, as of May 2025, all current generations of Graviton are available across the APAC and China regions. 4 regions lead the expansion with support for our latest Graviton 4 instances: Tokyo, Sydney, Mumbai, and Hyderabad. The largest variety of Graviton instances exists today in Tokyo, with 20 different Graviton EC2 instance types available. And we're working diligently to continue bringing the newest instance families to more regions in the coming months. Diversity across APAC is strong, which allows you to access the various Graviton instance types and generations you need to meet your workload price performance targets. And we're excited to continue the rapid global expansion of Graviton. In fact, over the past 2 years, over 50% of all compute landed in EC2 has been on Graviton instances. Now, as you can imagine, games companies with hit games use a lot of compute on EC2. Epic is one of thousands of companies running on Graviton EC2 instances, achieving significant performance gains and cost savings. Epic Games' rapid growth of Fortnite provided them limited time to think about optimizing the game servers. They needed a robust and scalable infrastructure solution to handle the massive scale of thousands of their game servers. They first began using Graviton 2 in 2020. Graviton provides that best performance per watt of energy use of all the instances on Amazon EC2. It uses up to 60% less energy for that same performance than the comparable instances. So you can learn how to compile Unreal Engine for ARM Graviton at the QR code shown here. So if you want to learn how to do that, grab that code. Now, since their original migration to Graviton 2 in 2020, Epic has utilized each new generation, and now they're on Graviton 4. And they're taking advantage of that 30% better compute performance with 50% more cores and 75% more memory bandwidth over Graviton 3 processors. And they shared with us that their Graviton instances are the most performant and fastest instances that they've ever tested. So speaking to infrastructure, modern live services games run backends to manage their various components. The multiplayer experience, the online game experience, things like authentication, player state, game info, and social systems. Now, as the backend is one of the first things that a game developer stands up, we've released a solution guidance for building your game backend on AWS. This solution is built with customization in mind. It covers the key building blocks for cross-platform authentication and game engine integration, and allows you to focus on developing the backend features that make your game unique. The identity component has been tested with a simulated 2.5 million concurrent users, and the whole solution utilizes managed and in many places serverless components to scale based on demand from development to large-scale game launches. Observability is included. It utilizes AWS X-Ray to provide you a distributed tracing solution, a service map, and a holistic view of the logs and the metrics down to the code execution level. The solution comes with a sample backend component template. It has container-based Node.js and serverless Python that you can use to start your development. You can also use any other programming language you want of your choice to develop the rest of the backend. You can learn more about this from the QR code. So now I'm going to go to the next slide. We're going to go through the flow for this. So this architecture diagram illustrates how the AWS Games backend framework is used to deploy a custom, lightweight, and scalable cross-platform game identity component, and how the identities authenticate. So let's walk through this identity flow in 10 key steps. The key management steps 1 through 3. The Lambda function generate keys runs. It generates a new JWKS public and private key pair. And then it updates S3 with the new public keys and stores the private keys in Secrets Manager. Next, the game client guest authentication flow, which is 4 through 6. The game client requests a guest identity via SDK. It then initiates a login as guest Lambda function to validate or create an identity and store it in DynamoDB. The Lambda function then requests the signed JWT token, the private key from Secrets Manager. Now, steps 7 through 8, the backend authentication portion, the game client uses the SDK to make authenticated calls with the JWT token. Then the backend validates the tokens using the public keys from S3 via CloudFront. Then the SDK, so that brings us to the token management step, which is step 9. The SDK automatically will refresh the JWT tokens through refresh access tokens Lambda call. And then we're at step 10, which is our platform-specific identity. With support for linking platform-specific identities like Steam or PlayStation or others, the game client can then send access tokens from the game platform specific identity provider to an existing account or create a new account. And this account can optionally be stored for you in Amazon Cognito as a user pool. And the Lambda function can validate the tokens and create the link to the user account with a specific DynamoDB table. Then it generates that JWT token for the client using the private key from Secrets Manager. So this architecture provides a secure, scalable identity solution that works across multiple gaming platforms while maintaining a lightweight implementation. So Harmony Games is a great example here. They were a new studio that was founded by some industry veterans. And when they were building their first game, Domino Adventure, they started out like every other studio, realizing they needed a backend for their mobile game. Selecting a game backend solution, as we mentioned before, is one of those most significant decisions that you make in a new game studio, standing up a new game. And the decision criteria varies depending on the type of game being released, the game launch timeline, and the available engineering resources, and the studio budgets as well. So building a backend from scratch can take a significant amount of time, where partnering with a third-party backend as a service provider is a common choice for startup game studios. But Harmony was finding that solution difficult to customize for their game. So the team at Harmony found the guidance for custom game backend that we've been talking about, and they found it compelling due to its open source nature, the built-in security, and the simplified deployment. In less than an hour, Harmony Games had a scalable serverless backend to support their game. Their changes and configurations that they made to it were codified into an AWS CDK template, which allowed Harmony to replicate the environment for further building. So if you need to build a game backend, be sure to check out the solution we've been discussing. All right, let's talk a little bit more about running games on AWS. Making a game is hard, and making a great game is even harder. So to make better games, you need information and game analytics. You need tooling to provide that information. A traditional game development loop may look something like this. So first, we want to measure impact, right? So the first step is to know what's happening in the game. Are players enjoying it? What are they doing a lot of? What are they not enjoying or doing, for example, could be part of that data. And then we want to set some goals, like what do our players want to do? What do we want our players to do? You know, there's often a lot of opinion between teams in a studio, but with real data, everyone can make an informed decision and align on the highest value goals. So this allows us to then prioritize our work. You know, team capacity is finite, and directing efforts to the most efficient goals to meet players' needs hinges on accurate predictions of any given project's impact. So now that we've aligned, we launch our changes. When the team believes that they've achieved the goal, it's time to release the changes to the players and testers. This can be de-risked through limited audience releases that validate the expectations with real data. So here are the analytics use cases that we commonly talk about with customers. While live services games naturally gravitate toward data-informed workflows, traditional premium games are made better at launch by using data during development. So taking a look at this list, are any of these important to you in what you're building today? Yeah. All right, let's move on. So we have actually a pre-built analytics pipeline for you to try out. So if you've developed a game, you know games produce a lot of data, and studios need that data to make those informed decisions that we were talking about. So using the game's analytics pipeline, solution guidance for the ingestion, storage, and visualization of your data provides a cost-effective and scalable way to discover actionable insights. The AWS Game Analytics Pipeline solution manages the entire lifecycle of analytics from ingestion to real-time streaming. It's to storage and then to reporting and even visualization. So the design scales to capture data in real time via a flexible system where your studio can decide whether to analyze it as it arrives or batch it up and store it for later. And you can find this example game analytics pipeline solution at the QR code here. In the next slide, we're going to look at that architecture that you'll see from this QR code. So this architecture diagram demonstrates a serverless analytics pipeline. It shows you the ingesting of the game's telemetry and the data that's provided from the developers, and it shows you how you will get the real-time insights through the flexible storage or analytics options. So let's walk through it in the 5 key steps. So the first is the data ingestion. The pipeline begins by accepting game telemetry data from various sources, game clients, servers, backend services, all through HTTP or HTTP REST endpoints. And then 2, we have our API layer. The incoming data hits a serverless backend powered by API Gateway, Lambda, and DynamoDB, which handle the authentication and route events appropriately. And then 3rd, we have our real-time analytics option. So we have these 3 here we're going to go through. So 3rd, real-time analytics option. For immediate insights, data can flow through Kinesis data streams to the managed service for Apache Flink and OpenSearch service, enabling real-time processing and dashboarding. And then 4, this flow is the data lake path. It's for batch processing. Data moves through Kinesis Firehose to S3, where it's stored in Parquet format, and AWS Glue processes this data, making it queryable via Athena for detailed analysis. And then number 5 is our data warehouse option. So alternatively, the data can flow from Kinesis data streams into the serverless Amazon Redshift, providing a robust warehousing capability with built-in processing and querying. So as you can see, the deployable game analytics pipeline on AWS solution can pre-bake exactly what you need to get started with creating your own data-informed games development loop. All right, let's talk about preferred deployment method. So as you take this approach, you can deploy via AWS CDK or Terraform to match your existing infrastructure stack. So you want to select between your data lake, Apache Hive, Iceberg, or your data warehouse, Redshift serverless approaches, and then you'll easily integrate with your existing CI/CD workflows and tools. So the comprehensive analytics capabilities and the deep insights into your games and players can come both from processing real-time events and historical data. You can also transform complex data streams with Apache Flink. You can create interactive dashboards with that OpenSearch service, and you can query the data efficiently by using Athena or Redshift. So this is a cost-effective and scalable solution, and you can start small and then you can grow it with your success. Minimize your management overhead with serverless architectures, where you pay only for the resources that you're actually using rather than having servers sitting there idle. So you can also benefit from automated performance optimizations, and you can choose optimal ingestion methods for your needs. So let's talk about this example of Notorious Studios. They wanted to get real data on what players were doing during playtests in their development game Legacy, and to validate design decisions early in development. So to capture the near real-time telemetry and derive insights relating to player preferences and gameplay optimizations, Notorious Studios deployed the game analytics pipeline and further customized it over 2 days. In just that amount of time, the company used these insights to accelerate game improvements and prioritize features that they found were having the best player impact. So they're a great example of what you could do with the data. So, what should we remember from all these things we've talked about today? So with over 16 years of experience supporting the largest games in the world, AWS accelerates development across production pipelines. Our solutions are used by games reaching more than 750 million monthly players, and we can scale to meet the demand of the biggest hit games ever created. AWS is that leading cloud provider building and running games in the world. So if we go from left to right here, our industry expertise and our bespoke solutions that we have available, AWS gets game development and how data and AI can help you make better games. Its flexible, serverless options, no matter your current or future scale, are cost-effective solutions to help build a data-informed culture. And we're built for data connections. AWS facilitates connecting data between disciplines, partners via low and no-code features, and even have data clean rooms and automatic quality and security checks for you. So if there's anything that you've heard today in the session that has you wanting to learn anything more, please just reach out to your AWS account team to discover how they can help you get started today. They'll be happy to connect you to any of these solutions or any of the partners that you've heard or have discussed today. Thank you.